Cambridge IGCSE Physics Paper 2, and the variant for this paper is 0625/22, and it's a February March paper. So let's start to question number 1. A student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The readings are shown. What is the average period of a pendulum? So in this question, what you need to do is, I'll be solving this over here. So first of all, you will divide 17.6, you have to add 17.6 plus 19.8 plus 17.6 plus 18.6. So how many readings are there? There are 4 readings. So you have to take the average of this number, and then he has taken the time period for 20 oscillations. So your answer will be 18.4. So then you are going to divide 18.4 with 20 to get the time period, average time period of one oscillation. So that is going to be 0.92. So option B will be your right answer. A tennis ball falls from upstairs window of a house. What can be said about the acceleration of the ball if air resistance is ignored? It depends upon the density of the balls. No, it's not true. It depends upon the mass of the ball. No, it's not correct. It increases as the ball falls. No, it stays the same as the ball falls. So this is your right answer. A car joins a road at a speed of 14 meter per second and accelerates 4 meter per second square for 5 seconds. What is the final speed of the car? So we know the formula is v minus u over t. Final velocity minus initial velocity divided by time. And now we will put the values. The acceleration is 4. We have to find out the final velocity. Initial velocity is this is 14 divided by time is 5 seconds. You can see this thing. So you do these calculations, so you will end up which is going to be 20 plus 14 equals to v, and v is equals to 34. So this is going to, option D is going to be your right answer. Okay, next question. The gravitational field strength is 8.8 newtons per kg on Venus and 3.8 newtons per kg on Mars. An object has a weight of 42 newtons on Venus. What are the mass and the weight of the objects on Mars? So what we are going to do is we simply divide this weight 42 with the 8.8 to find out the mass, which is going to be like 4.7, and then we have to multiply 4.7 with this 3.8, the value of g, and this is going to be 18.126. That is going to be the mass on that is going to be the weight on Mars. So option A is going to be your right answer. So you see this is 4.8, and this is going to be around, if you round it off, so it's going to be 18. So these two are your right answers. Okay, moving to the next question. A student carries out an experiment to find out the density of the rock. Which two measurement does student needs to make to determine the density of the rock? So first thing is that the measure one is increase in mass, and then increase in volume. Which two measurement does the student need to make to determine the density of the rock? So yes, this is the one which you need to do in order to find out the density of the rock. Okay, a car has a mass of 1500 kg. So this is your mass. A constant resultant force acts on the car, and the car accelerates from 15 meter per second to 20 meter per second in 4 seconds. What is the magnitude of the resultant force acting on a car? So we know the formula is F equals to ma, and this is going to be m is going to be as it is. We are going to write it and then it's going to be v minus u over t. This is the formula of acceleration. So putting the values, mass is 1500, the velocity is 20 minus 15, over time is 4. So if you do the calculation, so you will end up with 1875 newtons. So this is approximately 1900 newtons. So option C is going to be your right answer. A metal wire is loaded up to the limit of proportionality. Which statement is correct? Hooke's law is not obeyed when the load is increased from 0 to this point. When the load is increased beyond the limit of proportionality, the diameter of the wire is increased. When the load is removed, the wire returns to original length. Up to the limit of proportionality, there is no change in the shape of the wire. So option C is going to be the right answer, because this is the Hooke's law, and the object has to, whenever you remove the weight, it's going to come back to its original position. The diagram shows a uniform meter rule MN pivoted at its midpoint P. Two weights W1 W2 are hung either side of the pivot. The rule remains balanced. Which row is correct? The direction of the resultant moment about point M and the direction of the resultant force on the rule. So you have, so in this question, you see this thing that the rule remains balanced. So we are talking about equilibrium. So when we are talking about equilibrium, so what is happening over there? The sum of all the forces acting on the object and sum of all the moments that is acting on the object is going to be equals to 0. So option D is going to be the right answer for that thing. So both the direction of the resultant of the moments and the direction of the resultant force is going to be equals to 0. Which physical quantity is a vector quantity? So in this case, mass is not a vector quantity. It does not need any direction. So option D is going to be the right answer. A resultant force of 500 newtons acts for 10 seconds on a car of mass 1000 kg. This causes the velocity of the car to double. What is the final velocity of the car? So for this, like again, you have to use F equals to ma. So again, the formula will be like putting up the values. So it's going to be 1000, and this is going to be V over 10. So if you solve this, you will be ending up with 5 meter per second, and you have to do the double thing. So it's going to be 10. Option B is going to be the right answer. V times 2, where I mean is you have to double the velocity. A child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? From chemical to mechanical energy? No, this is not the case. From chemical to kinetic? No, this is again, after reading the question, we can easily omit these two options. From kinetic to gravitational potential? From kinetic to thermal? Yes, from kinetic to thermal. So this is going to be the right answer. At time equals to 0, a cannonball is stationary inside a cannon. The cannonball is then fired from a cannon. At time equals to t, the cannonball moves forward and the cannon moves backward. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between 0 and time equals to 0? Time equals to t. Okay, the total kinetic energy of the cannon and the cannonball is going to obviously change when it's going to be fired, and because initially they were at rest, and when you fired, so there will be a momentum. So, but if you talk about the total momentum, because it's talking about total thing, so it's going to be the B is going to be the answer, because the total kinetic energy of the cannon and the cannonball is going to be changed, and obviously it's going to be increased. And if you talk about the total momentum of the cannon and cannonball, because the cannon is going to recoil, so this is going to be constant. It is not going to change. In a small hydroelectric power scheme, 800 kg of water drops through a vertical height of 2.2 meters every second. The electrical output is 10.6 kilowatt. What is the efficiency of this scheme? So we are going to first find out the potential energy, which is going to be this. So it's going to be 800 times 10 times 2.2, which is around 17600 joules. Okay, and we have the output is this 10,600. We are going to multiply that with 1000 because of this kilo thing, because it's equals to 10 to the power 3. And then we will do this in 10 into 600 divided by, we will put it into the formula of efficiency, that is going to be 60%. So option C is going to be right answer. An object is at rest on a horizontal surface. Which equation is used to calculate the pressure that the object exerts? So it's going to be, we know the formula, pressure equals to force over area, and we also know that force is equals to W, and we can write it down W over A. So this is going to be option B. Smoke particles illuminated by bright lamps are seen through a microscope. They move about randomly. What causes this motion? Attraction between the smoke particles and the molecules of the air. Now a collision between the smoke particles and the molecules of the air. I think this is the right answer. Evaporation of the faster moving. No, this is also not possible. Warming of smoke particles by the lamps. No. So option B is your right or correct choice. Ether is a liquid that evaporates easily at room temperature. The rate at which ether evaporates can be increased by bubbling air through it. The diagram shows this process. Students give three suggestions why the rate of evaporation increases when air is bubbled through. So, student one, he suggested that the temperature of the ether is decreased. Okay, no, that's not possible. Suggest student two is saying that the surface area of the ether is increased. May be possible because that is one of the case in which evaporation increases. Student 3, he said that evaporated molecules are removed at a greater rate. Which students are correct? So 1 and 2, no, this is not right. 1 and 3, let me check. No, so option C is going to be the right answer, because the surface area is, if you increase that thing, so that is going to basically is going to increase the evaporation. So there are certain factors on which the evaporation is dependent, like surface area, the humidity in the air, or is the temperature, and the surface area again, and there are again certain parameters on which you can easily find it out. Some ice is slowly heated and its temperature is measured. A graph is plotted of a temperature against time. So this is the graph. So now you see, whenever you're studying graph, so you have to see the x-axis and y-axis, and now you see this quantities, and then this is, these are the three phases over here. Which row describes what happens to the thermal energy and the temperature in the section X? So in the section X, obviously this is not possible. It has gained some thermal energy, but the temperature will remain same. So it's the concept of latent heat of fusion and vaporization. So option B is the right answer. The diagram shows the apparatus needed for an experiment to determine the specific heat capacity of the material uh, from which an object is made. Which piece of apparatus could be omitted if the purpose of the experiment is to determine the thermal capacity of the object? So if you remove the balance, because for the thermal capacity, if you see this thing, so over there the mass is not required. For the specific heat capacity, the mass is required. Both boiling and evaporation involves change of state from a liquid to gas. Which row gives correct reference between boiling and evaporation? No bubbles are formed, so this is wrong. Occurs at all temperature. This is also wrong, because bubbles are formed in this case in the boiling, and then occurs at a specific temperature. So I have omitted these first two options. And occurs throughout the liquid. Yes, occurs at the surface only. So yes, this is the right answer. The temperature falls. No, the temperature remains constant. No, the temperature decreases. in the case of evaporation. Which statement describes the thermal conduction in metals by electrons? So, if you read these options, atoms are and electrons move freely throughout the metal. Now, the ripple changes the speed and the ripple hit the wall. Oh, my bad. Sorry, I was doing question number 22. 20. Okay, atoms and electrons move freely throughout the metals, and atoms and electrons vibrate about their fixed positions. So, yes, this can be a possible situation. Electrons move freely throughout the metal. Yes, electrons are the only causes of conduction in this when you are talking about thermal conduction or transfer of heat. So electrons are the only sources in which basically energizes or they vibrate uh, and then they transfer the heat. A tank container a tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripple to refract? Okay, in this scenario, you see this is what causes the ripples to refract. The ripple change speed as they move from deep to shallow water. So obviously, this is one of the reasons because I've read the other three options, though they doesn't make any reference or they could not be linked with those concept of refraction. Okay, the diagram shows wavefronts of a water wave passing through a gap in a barrier, which change will increase the diffraction of waves as it passes through the gap. So if you reduce the frequency of the waves, so this will give you this will increase the diffraction of the waves. Okay, so you reduce the frequency and you will get your required result. The diagram each shows a ray of light from an object O passing through a thin converging lens. The principal focuses in each diagram are labeled as and which diagrams are correct. So if you recall the rule for image creation, so you can understand this question. This is the optical center. So this rule number 2, it is the rule number 2, which says that if a light ray passes through optical center, is not going to refract. Okay, and rule number 3, yes, this is the rule number 3. So this is not correct. Image creation, if you recall that topic, so this is basically if the ray of light passes through principal focus, so it's going after getting into the lens is going to be parallel to the principal axis. So I'm making the arrows opposite to that so that you guys can understand. And so over here the option C is the right answer in this question. The diagram shows a ray of light inside an optical fiber approaching point X. The light is totally reflected with the fiber. The refractive index of the material of the optical fiber is 1.39, which condition ensures that the total internal refraction occurs. So in this case, you have to see this thing that this is your line. The light. This is your light which is entering into there. So in order to perform this thing, so the Q, this is what, this is going to be your critical angle. Critical angle. Because normally it happens like this. If this is it's going to make a 90-degree angle with it. So this is going to be gain if you solve this. So you see this thing, this is the formula for the critical angle. So if you this is n as the refractive index. So if you put the values into this, so you will get 46 degrees. So in order to perform total internal reflection, the angle should be greater than this thing. This critical angle. So option B is going to be your right answer. An eclipse of the sun happens when the moon comes between Earth and the sun. Which statement is correct? Infrared radiation from the sun disappears before the visible light and the ultraviolet. Ultraviolet radiation from the sun disappears before the visible and the infrared radiation. Now this is also not correct. visible light from the sun disappears before ultraviolet radiations and infrared. So obviously D is going to be the right answer for this question. The diagram shows air particles in the sound wave V, W, X, Y, and Z. Which rows correctly identifies the position of compression and the position of refraction? So basically you have to identify the position of compression and refraction. So in the compression, this is going to be your right answer for this, because these are the molecules are getting close to it. And in the refraction, the molecules are, like you can see this thing, this is what they are separated out. So option A is going to be the right answer for this. Two isolated matter spheres are both negatively charged. The spheres are brought closer but do not touch. Which diagram shows the charge distribution of the sphere? So this is not possible because the negative they repel. Again, this is not possible, so this is the opposite of this. So again, this is, these two are not possible. So this is what we have studied, that the like charges that they do repel. So this is the right answer. Two separate circuits have different power supplies. Both power supplies provide the same magnitude current. Power supply P has an electromotive force of 1.5 volts and the power supply Q has an electromotive force of 3 volts. Which statement about Q are correct when compared with P? Q supplies twice the charge per unit. Now, the Q supplies twice the energy per unit. So you can see this thing, it's 1.5 volts, it's 3.5. So almost we can say yes. And Q supplies twice the energy per unit time. So obviously that is the right thing. So in this scenario, option D is going to be correct. The diagram shows a piece of metal's resistance wire. Which wire made of same material has the smallest resistance? A wire of same length with larger diameter. Okay, so we have to see this thing, that rho L over A. So resistance is directly proportional to this and resistance is inversely proportional to area. So wire has same length, okay, and the larger diameter. Okay, so this seems to be correct. Let me read the next one. A wire of same length, smaller diameter. A wire of greater length. Now, because if you have because we need metal resistant wire, which wire of same metal has smaller resistance? So we need to find out the smaller resistance. So greater length will increase the resistance. A wire of greater length, and this is again greater length will not be possible. So option A is going to be your right answer. Which variable component in the circuit control the brightness of the lamp X? So now we have to see which instrument or which component is used to control the brightness of the lamp. So obviously it's going to be the variable resistor. So B is going to be the right answer. A circuit includes battery, two identical resistors, and 5 ammeters P, Q, R, S, and T. Which statement about the reading on the ammeter is not correct? So we need to find out which statement is not correct. P has a greater reading than Q. P has a greater reading than Q. So this is again, by reading this, both are ammeters. So they will be having the same reading. So this is not the right answer. P has a greater reading than R. P has a greater reading than R. This is true. Okay. And P has a greater resistance than S. Obviously, this is also correct. P has a greater reading than T. So option A is going to be the statement which is not. An electrician sets up a potential divider circuit in a fridge so that when fridge door is open and lights from the room enters the fridge, a warning light turns on. Which component does the electrician needs to use in addition to a variable resistor? So obviously it's going to be the light dependent resistor, which is detecting the light from the room that is going to enter in the fridge. So that will show the warning light. Two NAND gates are joined together as shown in this figure. Which single logic is equivalent to that? So we know this thing. Let's suppose that if we solve the logic circuit for this, we will end up with this, because we know the NAND gates are used for making OR gates and AND gates. The diagram shows an electric drill and a safety guard So you can see this electric motor is on the right side and the safety guard position is on the left side. The drill requires a logic circuit shown. The starting switch is on, off. Okay, these are the logics. For on is 1 and for off is 0. The circuit must only allow the motor to start when the safety guard is closed. So this is one condition. If the safety guard is not closed when starting switch on, the alarm must sound. So you must remember which logic is missing from the gate. Okay, so one thing is this, you see this thing when the safety guard lock is closed, then the motor should be switched on. So it's in this scenario what will be the, okay, so now you see this thing, obviously it's a common sense. So when it is closed, so safety guard is closed, you'll get 1. So over here it's 1, and when the switch is, when you are trying to switch it on, so it's going to be, the logic is going coming from here 1 and this is going to be here. So it's going to be AND gate because both have 1. So this will give you 1, because otherwise if this is 0 and 1, so that is not serving the purpose, because the purpose of the safety guard is to not to harm anyone or not to damage something. So if this is 0 and 1, so obviously the guard is not in its position, and when you switch it on, so there will no alarm and the motor will be turned on. So it should be like this, that both of these things should be switched off, and then both of these things should be 1. This is also 1, this is also 1, to make this work. So over here it's going to be the C is the right answer. 2 magnets are placed near a current carrying coil. The diagram shows this experiment arrangement and the current direction in the coil. Which statement is correct? Both X and Y are attracted to the coil. No, this is not right. Both X and Y are repelled by the coil. Yes, that may be a possible scenario. X is attracted to the coil and Y is repelled. No. Okay, the option B is going to be the right answer for this, and you can use the right hand grip rule to find out which is north pole and which is south pole, and this is going to be your north pole and this is north pole. So this is going to be repelled and this is going to be south pole and this is south pole, so they are going to be repelled. So you have to use your right hand grip rule. 2 circuits are set up as shown. The iron rods are placed close together and are able to move. What happens to the size of the gap of X when switch S is closed? So when switch S is closed, the size of the gap is going to increase. When a current carrying conductor is placed in a magnetic field, it experiences a force. Obviously, which statement about this force is correct? It is perpendicular to both magnetic field and the direction of the current. So I have studied these other options and I am skipping and coming to the right answers straight away. When a beam of alpha particle is incident on a thin metal foil, most of them follow the path represented by X in the diagram. A small number of alpha particles follow the path represented by the path Y in the diagram. So you see this foil is like this is moving into this, is passing through, this is reflecting, which rows correctly describe the conclusion that can be drawn from each of these observations about the structure of an atom. So atom is mostly it's mostly empty space, and atom contains something that repels alpha particles. This is what you get from this thing. Nuclear fusion is a reaction that takes place in star. Which row describe this reaction? So atomic nuclei joins together, they split is fission, FISSION. For fusion, this is like this, they are merging. Okay, they atomic nuclei join together, this is this, they join together to do this. But the correct answer is D, because a lot of energy is released, it's not absorbed in nuclear fusion. That's why you get energy from the sun, but you can't get it from the stars, because the distance between the earth and the stars is they are like very far away from the earth. When a radioactive isotope is set up close to a counter rate of 38,000 counts per second is obtained. The table shows the recount rate from the isotopes over a 3-year period. What is the half-life of the isotope? So how you are going to solve this question is going to be the B is the right answer. So now you see this thing, 38,000 is going to be 19, half of this is going to be 19,000, then it's going to be 900, 500. So you are basically uh, divided it by 2, and then it's going to be 4750. So I was basically checking that how many half-life cycle it has come up to this thing. So now we have to use other strategy to find out this thing. So I will be raising this strategy because this is not working over here. So I'll using the formula, which is remaining is what, 12,000 divided by what is the actual, that is this, equals to 1 over 2 times n, which is the half-life of this. So if you solve this, so you will end up with this number. Okay, anything which has power 1, any power to 1 is 1. Okay, so now you do the cross multiplications, and it's going to be 19 over 6, so n equals to 1.6. So it's going to be greater than 1 year but less than 2 years. So this is the right answer, because 1.66 means it is greater than 1 year but less than 2 years. Greater than 1 year and less than 2 years. So this is going to be your final answer. Thank you very much.